my name is Stephanie Villers. I'm an applications engineer with Applied Flow Technology. Today I'll be talking about how important and easy it is to bring your Fathom model into Impulse. As many engineers have found, modeling your system in AFT Fathom can save time and money over the life of the system. However, while you may have confirmed the steady state operation for your system, have you taken into account the potential transient problems that can occur as your system starts up and shuts down? For instance, how do the valves, pumps, and other components dynamically interact with each other during a surge event? What are the forces generated by transient pressures needed to design your pipe support? Are you complying with ASME B31.3 requirements for occasional loads? Does your system experience significant pressure surges due to cavitation? Do you have the right surge suppression equipment to mitigate potentially catastrophic effects of water hammer or surge and other undesirable system transients? Let's go through the process to see how importing an AFT Fathom model can speed this up by using one of the case studies from our website submitted by Fluor for our refinery cooling system. In order to size the equipment in a cooling water system, a detailed model was built analyzing the temperatures and flow rates throughout the system. Over 200 pipes and junctions were used to build a framework for the system, which was run in Fathom to verify the steady flow and temperatures in their plant. Here you can see that they modeled their system using heat exchangers with flow control valves. For each of the heat exchangers, resistance curves were used to model the loss, and they were able to use the heat transfer functions in Fathom in order to help them size these pieces of equipment. They were also able to size their pumps using assigned flow pumps within Fathom, as you can see here. While they were able to configure their system well for steady state operation, there was still questions about how the complex network would behave in the event of a sudden pump trip, and will there be surge issues after restarting the pumps in these conditions. When importing a model from Fathom into Impulse, we can simply change the file extension, then open it in Impulse. The file is converted as it is opened. To decrease the transient runtime, Impulse looks for ways to simplify the model and may present certain options, such as combining pipes in order to reduce complexity. After opening the model in Impulse, it is instantly clear that Fathom and Impulse share a very similar interface, though additional windows and tabs are now available for the transient run. You can see that certain junctions that are not applicable in Impulse have been removed that were there in Fathom, and additional junctions have been added to assist with analyzing different surge mitigation options. As the model was opened, Impulse automatically converted the heat exchangers, which are not present in Impulse, into general component junctions, but you can see here that all of the loss data was transferred over, preventing the user from having to re-add these junctions and re-enter all of the data. Similar to in Fathom XDS, within AFT Impulse, transients can be defined within the junctions either using time or single events based off of other occurrences within their system. In this case, there are only a few changes that we will need to make to the model. As stated before, all of the junctions and pipes have been brought in, and we'll just need to add a transient to the pump. In order to look at the pump trip and then startup, a speed versus time transient was used to first reduce the speed in the pump and then to restart the pump, all within one scenario. This can also be broken up into multiple scenarios to do more complex startup and trip events, as you can see here. For the last steps, we'll need to define our transient-only options within Impulse, which will be to section the pipes and specify transient control. We can see that when we open the section pipes window, Impulse will automatically begin calculating the ideal sectioning needed for the system. And we can select that here. For the last step, we'll just need to provide information on what we want to analyze during our transient. For the most part, there will not be too many changes needed to this window. Just primarily, we'll need to define what simulation duration we want to analyze for this case. And now you can see that all of our checklist items are done, and we're ready to run the model. In this case, when the model was run, Fluor found that they had several sections within their pipeline that had vapor cavities forming, which would need to be addressed for the final run. In order to address this cavitation within their model, Fluor added additional piping to make a more detailed model, and in order to size vacuum breaker valves at different points at which cavitation was occurring. You can see here that this is mid-process, and Impulse is giving you warnings specifically where it's having cavitation in order to help the user to specifically target those sections. As with Fathom, Impulse offers extensive graphing and visual report features to clearly understand the dynamic behavior, including tools such as graph animation and visual report animation. You can see here that the pressures along one path within the system were graphed here, and this profile graph could be animated to show how the pressure is changing along that pipeline, and in order to see when these low points are occurring and when these high points are occurring. Here we're showing another feature. As part of the visual report animation, we can see a color map of our transient values, and we can see the low points where there still might be cavitation problems occurring. And we can also see the high points here in red, where we might get pressure spikes within our system. After building a system for basic hydraulic analysis in AFT Fathom, importing your model into AFT Impulse saves 80% of your modeling efforts. AFT Fathom and AFT Impulse are designed to have a nearly identical interface, allowing you to jump quickly into running the analysis to design a safer and more effective system. Thank you for watching.